Even though this is the Ron Mallory Music YouTube channel, I also love science. I do science demonstrations for schools and kids groups, and my daughter Vivian's been helping me make some videos about some of my favorite science experiments. I have here a matchbook and a mug tied on opposite ends of a string draped over a pencil. Obviously, the mug is a lot heavier than the matchbook. So what do you think is going to happen when I let go of this end of the string? It might not be what you expect. Ready?
1, 2, 3, go!
So how did the matchbook stop the much heavier mug from crashing to the ground? The answer is because of something called the conservation of...
Angular momentum.
The conservation of angular momentum. The amount of momentum that an object has is determined by its mass and its velocity, the speed at which it's moving. An object's angular momentum is determined by its mass and the speed at which it's rotating. You've all probably tried this on a swivel chair or maybe a tire swing at a playground where you spin around, and as my arms are extended outward, I spin more slowly, and as I pull my arms and legs inward, I spin more quickly. Because of the conservation of angular momentum, as my mass distribution changes, as my size changes, the speed at which I'm spinning also has to change. You've probably seen ice skaters do this. I've seen video of astronauts doing this in their weightless conditions. And you might say, well, that's all great, but what does that have to do with the matchbook and the mug? When I let go of the matchbook, gravity is pulling it down, and just for a second or so, it's as though it's rotating around the pencil. But because the mug is heavier, it's pulling on the string so that the distance between the matchbook and the pencil is getting smaller. This causes the matchbook to rotate faster and faster, winding the string around the pencil enough that it keeps the mug from hitting the ground. Let's watch it again in slow motion. Ready?
Set, go.
This is something you can very easily try on your own at home, although for safety's sake, you'll probably want to practice over a carpeted surface. Experiment, be safe, and have fun! Okay, I'm going to spin you again. Ready?